Good morning, students. I wanted to go over for Principles of Engineering, Activity 1.1.2, Simple Machine Practice Problems. In this, you have 30 questions that should be done in your engineering notebook. Start out with a page in which you write Activity 1.2, Simple Machine Practice Problems. And in your engineering notebook, begin to answer the questions. There are 30 questions. There are 6 simple machines. This is very similar to what we've been doing in class with the builds. Sketch, pretty simple there. Calculate the actual mechanical advantage. In the question, they're giving you the variables, so you don't have to find them out yourself. And then there's one question where it asks for static equilibrium calculation. So I wanted to go over that real quick. If you go back to the PowerPoint, there is a moment calculation in which the moment is equal to the distance times the force. So that is the distance from the fulcrum out times the force being applied on the edge of the lever, or any one of the simple machines. In this case, it's a lever. So you simply measure from the fulcrum out and calculate the force. If you were to increase the distance from the fulcrum out, then you would simply have a greater moment. And so the question asks for static equilibrium. What it's asking for there is what it would take to balance the lever or any one of the simple machines. At what point would would everything equal 0? It would be balanced out. So you've got to set everything to 0 or set everything against itself. In this case, you see that we have a moment, which is, in this case, the R represents distance. So force times distance of the lever on the left side set to equal to force times distance of a lever on the right side. And you're given, in this case, you're given 3 variables and you're calculating the force. That's all it is. So if you look at one, you set ME to MR, the moment of effort equals the moment of resistance. When you break that down, you get the force of effort times the distance of effort equals the distance, the force of resistance times the distance of resistance. This is an example of one. So at what point can I make this level out? Well, obviously, with this shorter distance right here, I would have to have a great deal of force to equal something on this side, which would have a smaller force because there's a greater distance here. And most of the questions they're going to give you, all the questions, they're going to give you 3 variables, and you calculate, you solve for the fourth. If you're solving for a distance of resistance, you simply divide force of resistance out on both sides using algebra and solve for the unknown. This is due Friday at midnight. There's 30 questions here, but again, once you start going, you should be able to do it pretty quick. We'll have any questions, make sure you reach out to me in Discord or email me and let's chat about it, or I always can talk about it in class. For those of you that are virtual, this is a minor grade, but we do need to get some grades from the folks that are virtual, so make sure you complete this. There is a PowerPoint and there is a video on explaining simple machines. So make sure you take some time and do this. Don't wait till Thursday to start doing it. All right, talk to you later.